Hi guys, and welcome back again. Remember now is the question and answer segment where I shall expose you to a different types of questions, and then I'll give you also time to attempt that, and then we do our feedback as a collective. Right, now let's get right on to the questions. Name the three types of chemical bonds, okay? And then again, which two types of covalent bonds, two types of covalent molecules exist, give examples in each case. Right, I'll give you 3 minutes for that to try and respond to those two. Then quickly we shall do our feedback. Let's go for it, guys. Okay, guys, welcome back. Hopefully, you've made your attempt on the two questions based on the three types of chemical bond. Right, just to get right on to it, we know that we've got covalent bonding, right? We've got covalent bonding. Also, we've got ionic bonding is another type, ionic bonding. And we also have metallic, right? We also have metallic bonding. Right. Now we know that the covalent bonding consists of atoms. They can either be, they form molecules. These molecules can be molecules of elements or molecules of compounds. Take, for example, oxygen. We say it is an example of a molecular substance in which atoms of the same kind are joined together. We also have carbon dioxide as another example of a molecule of a compound. And now, typically, we say these occur between atoms or elements which are non-metals, right? So this happens with what? Non-metals, between atoms of non-metals. metals. Right, very key to remember that. And then as far as ionic bonding, we have metals combining with and non-metals with non-metals, right? Metals combining with non-metals. Now, what would happen? Primarily, the metals will form what we call the cations through the transfer of electrons. So what happens if they form cations? It simply means that electrons have been lost, and then the non-metals they will also form what we call anions, which gain electrons. So these are ionic or crystal structures. They form what we refer to as salts most often. Take, for example, sodium chloride as an example. Right. Now, and then in metallic bonding, this occurs between atoms of metals. Metals, which are typically the transition metals. We know the C of delocalized electrons and the positive nuclei, which happens to form due to the delocalized electrons moving between adjacent nuclei of atoms to form very strong bonds. That's why we say these metals have got very comparatively strong, higher strength in terms of the physical properties, melting point, density, as well as the boiling point. Then the two types of covalent molecules that we discussed today are the molecular structures, right? Molecular structures. Right, molecular structures are covalent. They are covalent, most definitely. Molecular structures are examples of such structures is, let's say, carbon dioxide. If you talk of carbon dioxide, carbon, when it bonds with the oxygen, if I may use that as an example, that's typically what happens. Now, this is a molecular structure due to shared valence electrons. Now, also, it can happen to form what we call macromolecules or network structures, such as diamond and graphite, network structures. This is another type of bonding which forms the macromolecules that we discussed, right? These are macromolecules. Okay. Now, the typical examples of these is graphite. We mentioned graphite. We also spoke about diamond, and also silicon dioxide or silicon 4 oxide, which is typical in sand, glass, and quartz. These are some of the most common materials that are used in everyday life. Right. So these are the typical examples. If we can maybe look at the next section of a set of questions, it has to do with also classification. It says here, copy and complete the table on each of the following substances indicated. Now, the emphasis is the name of substance given in words. So you'd identify the type of bond. Remember the three types that we spoke about, and then also the formula of the substances. Some of these can be elements, some can be compounds. Right. I'll give you say 3 minutes to do that. Then we shall do the feedback together. Right. Let's go for it, guys. Okay, guys, welcome back again. Surely we've made our attempt on the table in terms of completing the type of bond as well as coming up with the formula of each of the substances that was given based on today's session. Now, let's quickly go right through it. With the first substance is hydrogen bromide. I want you to be very careful. Bromide. It consists of hydrogen and bromine, right? Hydrogen and bromine. Right. Now, and it's bromine, but the name at the end is, if it's a halogen, it will end with the Di instead of an Ne. Now, remember, between hydrogen and bromine, there's sharing of valence electrons. Now, the type of bond in this case will be a covalent because of the sharing of, so this is a molecular substance, if you can think of it, right? Hence the formula, because there's one atom of bromine and one atom of hydrogen in a unit of these substances. Hence the formula will be HBr, right? Carbon dioxide, which is something that we have looked into. The di suggests that there are two oxygens. It consists of carbon and oxygen chemically joined together, but there are two oxygen. Remember, the sharing of electrons, valence electrons. In this case, the double bond, is we shall discuss later when we do the bonding. So the sharing part, which means this is also another covalent molecular structure, right? Covalent molecular structure. Carbon and then dioxide, that's the CO2. Then gold, the type of bonding, gold is a transition metal, right? Remember, this is a transition metal in that special block in the periodic table. So because it's a metal and it consists of atoms of the same kind. Now, these is a typical example of what we call metallic bonding. Because we discussed it as an example. So this is a metallic substance or a metallic element. So we just write down the formula unit as AU there, which represents the atom of that element, which is the basic unit of the metal. Right. And then potassium chloride. It consists of potassium as well as chlorine. Now, potassium is a metal and chlorine is a non-metal. So in this case, there is actually the transfer of electrons taking place between these two substances, with the potassium forming the cation and the chlorine forming an anion. Hence, this is then the strong forces, or which we call electrostatic forces, join these two ions. So these are electrostatic forces, or sometimes we refer to them as Coulombic forces, right? Coulombic forces, but the type of bond involved in this case is indeed ionic. So the response that we're looking for is ionic, but remember, ionic consists of electrostatic forces between the cation and the anion, between a metal and a non-metal. So there's one potassium, we always start with the positive one, followed by the negative in one chlorine atom. So for that reason, it gives us that. Okay, let's look at the last set of questions, which is also in the form of a table. Right, in this case, we've got elements present. We want the type of compound and the formula. I think we get the type, the sense of what we want here. So this is the elements in terms of the composition. It can be a single element, it can be two or different. If it says and, it means they are generally chemically joined together. So it would not necessarily be a compound. It would be, let's say, a substance, just to generalize that. Right. Okay, I'll give you 2 minutes for that, and then we will do the feedback and wrap it up. Let's go for it, guys. Hi again, guys. Welcome back. After our short attempt to this very last program, last question in our question and answer session, let's look at the feedback together. Now, the elements present in this case is magnesium and oxygen. Right. You remember magnesium is a metal, and then oxygen is a non-metal. And obviously, there shall be a transfer of electrons involved. In this case, this is an ionic substance or ionic compound because of the transfer of electrons. Right. Hence, the formula, because magnesium is in group 2, oxygen is in it forms a magnesium 2 plus ion. So for that reason, we get the formula MgO. Right. Then for hydrogen and oxygen, depending on the number, if it was 2 hydrogen and the oxygen in terms of composition, we can immediately think, say, of water, as a substance. We can think of water. Now, water has to do with the sharing of electrons or valence electrons between hydrogen and oxygen, which means in this case, it will give us a covalent molecular compound. So this is a molecular substance. In other words, in this case, it's a compound again. So it will be H2O, right? And then magnesium and chlorine, it has to do again with the transfer. It means once we mention transfer, it takes us to ionic between a metal and a non-metal. So in other words, we've got MgCl2, which is very important. We shall discuss how we come about with the two there in terms of chemical bonding, which is the next lesson that I anticipate. Now, if we look at the copper atoms, this is an element, hence we refer to this as a substance, and this is a transition metal. So indeed, this is a metallic substance. Is a metallic substance, so you just write the unit there, which is the atom, or the formula unit, which is the atom of copper. Then carbon forms what we refer to as the giant molecular network structure. This is a covalent network structure. This is a network structure or a giant structure. It can be, let's say, for example, which is covalent again, a network covalent. But this one is a giant structure, which you can think of, they say carbon in the form of graphite, graphite, it's just C, it could be carbon, it could be diamond, just to mention, remember the allotropes that we discussed. So this is basically, these are covalent at the end of the day, which forms a network or a giant structure, like I've said earlier on. Right. Now, this brings us to the end of today's session. There are quite a lot of things that we discussed, but what is it that we take home, as far as chemical bonding and in terms of compounds and atoms of elements? There are three very critical ones. We mentioned covalent, molecular, we also dealt with network structures, which are lattice structures, the giant, which is a molecule. We also spoke about ionic compounds, between metals and non-metals. We also spoke about metallic. So these are the key aspects that we dealt with today. Hopefully, this was an interesting session from myself, Temba Ngube. I think we shall meet again in the next section. It's cheers and bye-bye for now.